Okay, this is the optimization practice that we had today, and this is problem number 1. And the first thing I'm going to say is we do not want to have two different amounts for the volume, so we're just going to go for the 355 milliliters. So we are optimizing the dimensions of the can, and we want it to be a minimum, so the least amount is used. And in this case, we're going to talk about the surface area. So if you recall, the surface area is the circumference times the height, that is basically the label, plus 2 pi r squared, which is the top and bottom of the can. Okay, so we also need to talk about our constraint, and our constraint in this case, let's just go ahead and write that, is going to be the volume formula, which volume of a can is the area of the circle or the base times the height. What you have to think of is a bunch of those circles are keep piling on top of each other to get the volume. And what we are given is the 355. So what we want to do is we want to have the surface area in one variable. And in this case, we're going to put it in the variable of r, the radius. So what we have to do is we have to isolate that h. And the way we would do that is to divide everything, all the pi r squared, so that is what our h is. And we are going to put that right up there. We're going to substitute that into the surface area formula so that we will have one variable for that surface area, and it's going to be the r, so we're going to have 2 pi r, and then our h is that 355 pi r squared plus our 2 pi r squared. So now, to simplify that out, we would end up with those pi's go to 1, the r's, one of those goes to 1. So we have 2 times 355 over r plus our 2 pi r squared. And when we simplify that out, 2 times 355 is 710. So we have 710 over r plus 2 pi r squared. So that is our surface area with one variable, r. And so we want to take the derivative of this so that we can find what the radius is. Now, if you recall, if this r here, we want to put it as r to the negative 1. So the derivative of that would be negative 710 r to the negative 2 plus 4 pi r. And again, you guys, remember when this is negative, we can move it down to the denominator. And what we want to have happen here is we want to have these both to have this common denominator of r squared. So in order to do that, we have to multiply the top and the bottom by r squared. So I'm going to turn around and move these around in the front. So we have pi r cubed minus 710 all over that common denominator of r squared. So now we want this to be equal to 0, and that will be minimizing based on the derivative. So in order for that to happen, we just need to worry about that numerator. So when I set that 4 pi r cubed minus 710 to 0, we're going to solve for r cubed, and we would be adding the 710 and dividing by 4 pi. So we have r cubed is equal to 56.5, and we take the cubed root of that, cubed root, and we get r is equal to 3.837, so we'll just say 3.84. And then to find the height, we are substituting that radius in to our height formula, which would be the 355 over pi r squared. And that gives us 7.66. So those are our two solutions. We have the radius and we have the height. All right, see you next time.